Hello, my name is Gary Adams, and welcome to our Silicon Motion EE Times presentation of the critical role of SSDs in maximizing AI storage infrastructure. Let's share the mandatory slide. Taking a quick snapshot on Silicon Motion, we are the go-to market leader in merchant NAND flash controllers and solutions, with over 22 years in working with all NAND suppliers. We provide differentiated solutions across data center, PCs, smartphones, automotive, and industrial markets. And today, we'll be highlighting what we're doing in enterprise around AI. AI is everywhere today. Use is ubiquitous across generation lines from grandmas optimizing cooking recipes, the use of driverless cars, to kids getting assistance with homework. AI is increasing work efficiency, providing personal and personalized assistance, increased productivity, providing safer driver experiences, and more convenient living. In 2024, Statsa Research Development said that people using AI tools passed 250 million globally, and that number is expected to push past 700 million in 2030. All of this is possible by the explosive growth in AI large language models. And while GPUs have been the focus and are tasked with growth in compute, we observe model growth from millions to trillions of parameters simultaneously with a similar growth in dataset sizes, all of which require high efficiency storage of data. Now, looking at the large language model AI data pipeline, it is really considered to be a comprehensive framework designed to manage the flow of data through various stages from collection to deployment. It ensures that data is prepared, processed, and utilized effectively for these large language models and machine learning. SMI is digging deeper onto what is needed to be done within the SSD to maximize data efficiency and minimize total system power while reducing training completion times. And as we look at each of the stages of the AI data pipeline, we'll start with ingest. Ingest fetches raw data from external sources, potentially all the way down to IoT devices. This data is unstructured and stored in raw form. In preparation, data is modified, then stored in format convenient for feature extraction and model exploration. And in training, the GPUs select batches of input data, models random walks back and forth through multiple passes to develop that AI model. However, we do see the need for checkpointing that saves the state of that training, and this is a high potential issue for GPUs being left idle. And the reverse is worst case when a restore from a training issue occurs. And lastly, in an inverse, we run into a new and live data. Once these processes are completed, you have an AI product that can be put into devices such as cars or phones. AI training is no longer for just core data center only. We see the decentralization of compute and storage from core to edge. Real-time inference and lightweight training are done locally versus batch processing in the data center core. The far edge has more localization constraints and platforms based on security, maintenance, or air handling needs. Examples of this may be cell towers or robotic manufacturing. Edge storage growth is going to be 2x that of the data center core, and we see the acceleration of HDD replacement with higher performance SSDs from core to edge. SSDs have the critical role to play in the AI ecosystem, and it's clear that we need to focus on how flash is managed. They'll be the unsung hero for enabling faster, more efficient, and secure AI. AI generates tons of data that requires large capacity SSDs. AI computational needs to be fed data quickly, so data efficiency is key. And AI consumes an unprecedented amount of power, so performance per watt has to become a focused benchmark across all markets. And lastly, AI privacy is more important than ever when AI moves to device. The personal needs to be secured. SMI, as leader is off-the-shelf SSD controllers, has a comprehensive strategy for AI, starting from the enterprise core to edge, AI consumer edge personal devices, AIoT, the automotive markets, and with all markets touching the human experience. However, today we'll be discussing enterprise needs. Starting in the heart of enterprise for SMI, we have our MonTitan development platform. It provides a purpose-built firmware, hardware, and ASIC technologies that work synergistically to address customer needs. MonTitan is composed of an SSD controller ASIC, standards-based reference hardware design kits supporting EDSFF and legacy form factors, as well as a layered firmware stack supporting both standard NVMe and host-based FTL usage models. The 8366 is the MonTitan platform's high-performance ASIC. It is a true dual-ported PCI Express Gen 5 interface targeting both enterprise storage and data center compute applications. With 16 channels running up to 2,400 megatransfers per second and having DDR5 interfaces, it provides industry-leading, blazingly high performance. And performance matters. With 3.5 million IOPS of random performance, this is 20 to 30% better than any of the other off-the-shelf suppliers' advertised specifications. And faster model completion times are provided for graphical neural networks and large language models. MonTitan's core has a platform architecture and it is firmware defined and hardware accelerated. It's going beyond having a high performance data plane. It focuses on control plane efficiency and coherency with key hardware accelerators and processing elements. This is perfect for AI applications. And for data center or large enterprise organizations, the storage of the entire AI data pipeline is implemented in tiered, centralized, and unified data center storage. The challenge for high-capacity SSDs is multi-tenancy, as the same data can be attempted to be accessed by different stages of the pipeline. This is called the I/O blender effect. Thus, having creative methods to isolate the guaranteed traffic in different stages of the AI pipeline are critical for quality of service to maximizing GPU utilization. We are focused on how more efficiently maximize the potential of NAND within the SSD. Optimizing direct data placement technologies like zone namespaces and flexible data placement, we can shorten latency, improve performance, and endurance for all AI SSDs. This provides overall less solution power, giving back more budget to the GPUs. Flexible data placement helps mitigate the I/O blender effect. With mixed read and write requests to the storage system resulting in unpredictable I/O patterns and lower consistency, FDP sequentializes writes, reducing write amplification, improving endurance, and write performance. With SMI proprietary performance shaping technology, the host, either an AI server or AI storage server, will define a QoS set and configure QoS sets dynamically using dual stage shaping algorithm. This configures for specific applications running for specific workloads along the AI data pipeline, promoting isolation. Performance shaping can shape hundreds of workloads just in one Gen 5 SSD. We are focused on performance per watt as key benchmarks for AI prep and training. How does SMI-based SSDs achieve this? From an ASIC perspective, we provide power islands, frequency scaling, and fast retry and exit in low power modes. We leverage more advanced fab processes. We have lower power L2PC technology architectures with intelligent on-device training to increase performance while reducing error correction possibilities. Advanced firmware is also provided for direct data placement, power scaling, and performance. Privacy is the key for on-device AI. SMI's on-device tamper-resistant and data encryption engine hardware helps protect personal data and storage. Our end-to-end data protection and controllers prevent hacking. And we continue to make investments in enterprise-focused root of trust, Calyptra, and post-quantum cryptography technologies. Digging in a little deeper into SSD data integrity, data is stored with end-to-end data protection with all memories and DRAM interfaces being protected with error correction, removing concerns for silent data corruption. In addition, providing data security is paramount. With the support of the latest NIST FIPS standards and global requirements for data at rest, the enterprise features for data encryption and key management features are provided. And at platform level, the root of trust provided with Calyptra, authentication with SHA and SM3 hash functions, and in addition, post-quantum encryption is supported. And talk about high capacity, we focus on the need for cost per terabyte as the leading metric for AI SSDs supporting ingest, inference, and checkpointing stages. SMI is the collaboration and innovation partner on QLC enablement. First, leading with the development of the PC QLC SSDs, SMI continues to pioneer the way with the market's first enterprise Gen 5 QLC SSDs. And going beyond nearline HDD replacements, AI's demands the near high performance and high capacity SSDs that are uniquely enabled with larger die NAND. However, new innovation is required when we move to increased number of NAND layers to provide cost-effective, lower power solutions for these high-capacity QLC SSDs. SMI's 8th generation of NAND Extend technologies enhances QLC reliability and reduces error correction latency. We are adding channel processor hardware engines to accelerate NAND machine learning, and this flexibility enables the stable performance and reliable data protection across platforms. Multidimensional SSD performance is done by maximizing the AI pipeline performance. High performance PCI Express Gen 5 we start with. We incorporate FDP to optimize direct placement and QLC SSDs to maximize write performance. Then we layer on top SMI's patented performance shape technologies to optimize QoS for each workload along the AI data pipeline. Then this enables us to isolate concurrent SSD access by multiple stages in multi-tenant environments and assures performance on streams of data to maximize each individual GPU performance. Here at SMI, we have launched our high-capacity QLC SSDs, ranging from 16 to 128 terabyte SSDs among a number of the standard and EDSFF form factors, ranging in power from 25 to 40 watt envelopes. So in conclusion, storage is critical to driving force enabling faster, more efficient, lower power AI applications. High capacity QLC SSDs are key to providing lower cost per terabyte AI storage from core to edge. And SMI provides a comprehensive AI strategy in providing SSDs that have data efficiency, power efficient performance, data reliability and security, and high capacity storage. Thank you for listening to our talk today, and thank you.